Now, if you're going to be working in any type of Microsoft administration services these days, there are some fundamental principles that are very important that you understand. So what I want to do is I want to get into some of the foundations of understanding things like Microsoft domains, understanding some of the networking technologies, RAS and VPNs and virtualization, and also we're going to talk about the cloud services and how all that fits into this. But it's important to kind of start from the beginning so you can understand where things have been, understand where things are going, and you have to consider the fact that the world is transitioning now more into a cloud-oriented environment. But in the past, everything was managed on-prem or on-premise, and we got to talk about this transition and how things were and how things are now and where Microsoft is going. So to start with, we go back in time to the 1950s, 1960s. They had mainframes, these gigantic computers that would take up like entire rooms. They used vacuum tubes. And then as we moved into the 1970s, something miraculous happened. They created what was known as an IC, an integrated circuit, which allowed basically binary math to be processed through little chips. And this is where personal computing became popular. So in the 1980s, personal computers started coming out. I'm going to draw this little symbol here to represent a computer. And I tell you what, I'm going to create another little symbol here to kind of represent a bunch of computers. So in the 1980s, companies started buying PCs and personal computers, and they started showing up in people's offices, and eventually, they were networking them together and all of that. And so this is where things really get started. Now, of course, in those days, one of the problems was we lived in what was called a peer-to-peer network. So what would happen is these computers you could network these computers together with various technologies, but there was no centralization, meaning each computer was equal. There was no computer that controls all the other computers. A network admin would have to, if they wanted to make changes, they'd have to sit down at each and every computer to make those changes or get users to help them, which was always a nightmare. And so that didn't, it worked, but it didn't work very efficiently, all right? Now, as we moved into the 1990s, there was a company that was gaining ground called Novell, and they had a product called NetWare, which was, the idea of that was to use a server that would help manage machines and also allow people to share files easier, whereas in a peer-to-peer network back originally, these machines would have to share files with each other and people would have to know each other's passwords. It just didn't work very well. Well, eventually with the creation of the file server concept, you had a more powerful machine that you could share files on and all that, and eventually Novell even came out with the idea of a server that could manage other machines. Now this is kind of where Microsoft comes in. Microsoft created their product called NT, and they created this concept of a domain controller, which is a special type of server that can manage these other servers. Now, fast forward, they came out with what was known as a domain, but fast forward to the year 2000, Microsoft releases their newest domain technology, and they call it Active Directory. And Active Directory domains were represented by a triangle. All right, and a domain controller was a server essentially that had a database on it, and that database was the Active Directory database. So let's just kind of fix that here. This little cylinder looking thing I'm going to make here is going to represent my Active Directory database. So AD. All right, and this is what we still call to this day. We call it ADDS, Active Directory Domain Services. And usually if you hear that term, Active Directory Domain Services, it means it's an on-premise domain. Although there is a version of this that can be hosted in the cloud known as Azure Active Directory Domain Services. I'm not getting into that right now. So anyway, you would always want to have more than one domain controller. The reason you want to have more than one domain controller is because the same reason you have more than one of any type of server, really. One reason being to break up the disbursement of load, these machines will authenticate with these domain controllers, and the more machines you got, you don't want all of that just going to one domain controller, right? The other consideration is redundancy. If you only have one and that server goes down, well, you're in trouble, right? So we want to have multiple. The other thing about domain controllers that are interesting is that they replicate. So, for example, I'm going to make a little smiley face guy here, and this little smiley face guy is going to represent my user. So we create a user account on a domain controller. Now, the interesting thing about user accounts, or the interesting thing really about domain controllers, is that they replicate. So everything you do on one will replicate over to the other. So if I create a user account on that first one, well, replication is going to occur between both of them. And so this little arrow thing I'm going to make here is going to represent replication. So domain controllers replicate. That means that this user could log on to any one of these thousands machine, and it's going to authenticate with the domain controller. All right. The authentication protocol that is used is the protocol known as Kerberos. All right. Kerberos is the authentication protocol. What is a protocol? It's like a language, basically. Okay. Now there was an older protocol that it also supported called NTLM. That was for legacy, for older prior to the year 2000 machines. Now that protocol allowed us to have encrypted passwords and all that, and authenticate securely and all that fun stuff. The other thing is Active Directory uses a language known as the Directory Service Language, and that language was called LDAP, Lightweight Directory Access Protocol. Now all that is, again, this is all decades old at this point. At the time when it came out, it was cutting edge, but it is a bit dated nowadays. But it still works, and it's still pretty secure, though there are some considerations on security that I'm not going to explain right now. Now, the other thing that's important about Active Directory is that all machines have to have a name. And the name must be, of course, associated with an IP address and all of that. And so there is a service that we use it on the internet all the time, called DNS, Domain Name Service. Our domain must have a name. Usually when you name your domain, you would name it after your company, and a lot of people even name their domains based on their web presence. So for example, my domain might be called examlabpractice.com. That's my company, my web presence. And I'm going to need to have a server in my domain that can associate the names and IP addresses together. So that server is called a DNS server. DNS, Domain Name System Server. And that server will also have to have a little database on it, and that database will be our DNS database. Okay. So we'll just draw another little cylinder, and what I'm going to do is I'm going to highlight this, border it with red, and then I'm going to color code the database red, which means that this database, the DNS database, is associated with that name. Now what happens is our machines, clients, domain controllers, we also might even have, let's draw a file server over here. Pretty common that we have file servers in our environment. Okay. All of these machines would register with our DNS. All right. And this allows for the centralization of name resolution, meaning they register their IP addresses into this database, and then now anytime a machine needs to find another machine, it can query DNS. So for example, these machines all have to authenticate by your domain controllers. They can query DNS and say, hey DNS, do you know what the address is of one of my domain controllers so I can authenticate? And DNS can reply back and say, yeah, here is the information. At that point, the client can go and authenticate. So it works very efficiently. Now all of this together, this idea of domain controllers, this triangle you see here, this provides centralization. So we moved away from peer-to-peer networking back in the day where every machine was kind of its own boss and there was no centralized way of managing things, to now we are working in a centralized environment. These domain controllers help us centralize. This DNS service helps us centralize. So we now have some central control over things. One of the great things about our domain controllers too is we have these wonderful things called GPOs, group policy objects. A group policy object is this object that you can create that has all these settings, parameters, any type of attribute you want to configure or change on machines, you can do it through a GPO. So for example, if your boss walks up to you and says, hey, I want you to force the firewalls to be turned on all these machines. I want to make sure that the antivirus is always up to date. I want you to disable some of the wallpaper feature. I don't want people putting crazy wallpapers on their machine. So I mean, the sky's the limit. There are literally thousands of things you can do inside of a GPO. But what happens is that GPO can instruct these machines to turn things on and turn things off. GPOs also replicate. So when you create a GPO on a domain controller, it replicates over to the other domain controller. So it doesn't matter which machines authenticate with which domain controller. All right. So these GPOs can be deployed out to these machines, and this is how you turn things on, turn things off. You could even deploy software with that if you wanted to. So it was very, very powerful, a very, very powerful system for managing everything. All right. Of course, let's throw the internet into the mix here. Let's say that this little cloud is going to represent the internet, and let's talk about a little bit about how that sort of fits into the picture. Let me just clean it up here with the mighty stroke of my paintbrush. I will clean up the internet. All right. All right, so then we have the internet, right? So maybe we've got an internet connection that's coming in here. All right, and of course you don't want to just leave your internal network exposed, so your company would generally have a firewall, right? And we'll just put that firewall right here. And so now we have a secure way for traffic to flow out to the internet, and the only things that can come in would be things that we send out, and we could allow things through that firewall if we want to. Now, this is a traditional domain. This is the way we've done things for 20 years, all right? And in this next little section, I want to talk about expansion on all of this and where things have gone with things like RAS and all that, and VPN and virtualization. So that'll wrap this little section up, and we'll move on to the next. I now want to talk about some concepts that are also sort of the foundation of how we've done things over the years. It's important to understand how we've done things over the years so we can understand how things are now. So looking back, we have an Active Directory domain, ADDS as it's called, Active Directory Domain Services, which uses the LDAP, Lightweight Directory Access Protocol, which uses Kerberos for authentication, or for the legacy back in the 90s devices that used NTLM, New Technology LAN Manager, which isn't all very new these days, but even Kerberos is pretty old considering we've been using it for decades, and I think actually the protocol even came out back in the 1980s. So we got some data technologies, but the technologies have been updated, a lot of them over the years, to be secure, so you can still feel comfortable using those. But let's talk about some different scenarios now. The first thing I want to look at is the scenario of what happens when we have a user who is not at the office. So this person is working from home. Working from home is a lot more popular nowadays than it has been in the past, so it's very common. And this person needs the ability perhaps to be able to connect in and access services that are inside. Okay, and we've got a file server, but ultimately you probably are aware that in the past it was always this mindset of do it yourself, host your own server. So your companies might have a file server, but then they might also have a they might have a SQL database server that users need to access. Let's create that SQL. All right. Maybe Microsoft Exchange. That was email, right? Microsoft Exchange was used for email, and then maybe even like SharePoint was very popular. by Microsoft on premise. So here you've got these, these 4 servers providing a service to our devices, and you've got users working from home and everything else needing to get access to those. Let me just kind of move those a little bit over here, make a little bit of room here, and I'm going to shrink those down just a little bit as well. All right. So this user who is working from home needs to access these services, but the person is not, not around. Well, let me tell you what you shouldn't do. You shouldn't just open up all the ports on the firewall and allow this person in to get access to these devices unsecurely. In fact, in the 90s, a lot of companies did that. The very first company I ever worked for, back in the 90s, they didn't really have a firewall, so you literally could share out you had a public address, and you could connect to it from home. It was really scary when I think about it. Even in the 90s, that was scary, but nowadays it's incredibly scary. Why is it scary? Because you got these people out there that want to do things that they shouldn't do, and get access to companies' data and try to do damage and ransom and all of that, ransomware and all that. And who are these people? Well, we generally call them hackers, right? So let me draw a little hacker. This little box here is going to represent my hacker. All right, and let's make this hacker look like he's up to no good. All right, I'm gonna give him let's give him like a devil horns, some devil horns here, and maybe he's in a bad mood. I'm gonna give him a frowny face, and give him some fangs, and maybe the fangs are dripping blood okay, no, I'm just kidding. Sorry, sometimes I get carried away. All right, but anyway, that's going to be my hacker. All right, goofy looking little hacker person. All right, and so we don't want this hacker spying on my user. We don't want this hacker getting access to resources inside. So how do we get around that? Well, usually the way we would do that is you would use a VPN, a virtual private network. So the way you would do that is you could purchase what was called a VPN concentrator, and basically it's a device that allows secure connections in. But in the Microsoft world, we actually had a type of server we could set up called a RAS server, or also known as an RAS server because it stood for routing and remote access services. But anyway, remote access services is the idea here, and with that we have support for VPN. Now what does that do? This allows this thing called a VPN tunnel to be created, which means that you have this encrypted communications that goes through to that RAS server, and then from there that RAS server allows you to access other resources securely. This hacker will not be able to see the traffic that's flowing through because it's all encrypted. The only thing the hacker would be able to see is that it was going up to this firewall, and that would be it. Wouldn't be able to see what the traffic said. So this is how we would definitely help secure things. Now, the other thing that I want to talk to you about here is what happens when a company needs to have a service that is exposed to the internet. For example, let's say that your company is going to host their own web server, okay? So you set up a web server. All right, maybe this is going to be www.examlabpractice.com or whatever, and people from the internet need to be able to get to it anonymously. Well, how are you going to do that? Where are you going to put that web server? Are you going to put it internally inside the domain like you see here? And the reason that's scary is because you would have to open up port 443, port 80, which is HTTP ports, to allow traffic to get in, which means not only could somebody out there on the internet anonymously get into this web server, but technically so could a hacker. And if a hacker was ever to gain access over this website by hacking it, then something called pivoting could occur, where a hacker could actually gain access to these other services that are on your network. And so that's where things are really scary. So you definitely won't want to host it internally most of the time, although there was a way to do something called a reverse proxy. I won't get into that right now. But we would probably want to put this outside, right? So we'd want to put it out here. But there's something else that's a problem on that. If you put it outside that firewall, you don't have to worry about people getting allowing traffic to come in. But the scary thing about that is the fact that this poor web server is now completely exposed to the internet, so with no protection. So the way around that usually is people would get another firewall. So you'd have two firewalls. This first firewall would be called the internal connected firewall, and then this firewall here would be called the external connected firewall. Now this little network between that, we would call that a DMZ, demilitarized zone, or now the more popular term is perimeter network. Okay, so DMZ, perimeter network are basically the same thing. All right. And so now what you would do is you would only open the ports like port 80, 443, 53 for DNS if you put DNS in there, whatever ports there that you need, and now traffic would be able to get to this web server. Okay, and so even if a hacker somehow hacks this web server, you're not going to allow traffic to pass through this firewall and get to these resources. The only traffic that you might allow would be VPN. Okay, and there's a bunch of authentication and all that has to happen to make that work. All right, so that's the idea of remote access and VPNs in a nutshell for you, as well as the concept of DMZ and the perimeter network idea. Now, the final thing I want to look at with you in this video is the idea of virtualization. So I talked about how in the past it was always the mindset was we got to host everything ourselves. We got to have our own little data center. We got to have our we got to have our own servers, file server, SQL, Exchange, SharePoint, all that, and it's all got to be hosted by us. And that's the way things have always been done. All right. Now, then what you'll find is as time went on, a company called VMware came out with a way of expanding on virtualization. Just so you know, virtualization is not a new term. Virtualization has been around for a very long time. In fact, the term hypervisor is essentially the software that lets us emulate hardware. And if you can emulate hardware, you can also store software on that emulated hardware. That's the idea of virtualization. That term hypervisor has been around since the 1970s. The idea of even mainframes dividing up processing time and doing shared computing was a form of virtualization. So this is not a new concept, but VMware, they expanded on this idea, and the thing that they did that really pushed the envelope on all this was that, hey, you don't necessarily need 4 different servers. And here's the other thing. Here's the other crazy thing. If you wanted redundancy for those 4 servers, you'd really need 8 servers, right? You could do clustering those together. So you'd have 8 servers to provide redundancy for those. But with virtualization, I can set up a hypervisor server, 1 server, and virtualize those other servers. Now, in the Microsoft world, we call that Hyper-V. That is the software that does this, Hyper-V, hypervisor. Microsoft's not the one that came up with that. VMware is not the first to ever come up with that. VMware was the biggest contributor to this concept, though, so I do have to give them credit where credit is due. All right, now the other beautiful thing, though, about this is you get a really, really powerful machine. You virtualize your machines on those. You get these things called checkpoints in Microsoft. They used to be called snapshots, and a lot of other companies still call them snapshots, where you can make changes without the worry of breaking anything because you can revert back to before the change was made. The other thing that's wonderful about using virtualization is if I want to have complete redundancy, I don't have to have 8 servers. I could literally, purchase another server and have a copy of the virtual machines on that other server. Now I've only got 2 servers as opposed to having to have a total of 8 servers. Okay, so this is a very powerful feature capability that kind of started everything. Another thing that we got, and this is kind of where you start thinking about cloud computing, is with virtualization comes the term elasticity, which basically means that each of these machines can be given a certain amount of RAM processing power. But here's what's interesting about that. If one of the servers isn't using all of the available RAM that it's been given, it can share it with other servers. So for example, this file server has been given more RAM than it needs, and then SQL needs that RAM. The file server can give up some of that RAM over to SQL. And when SQL's done using that extra memory, it can release it back to everybody. it's basically a pool type scenario where it gets released into a pool of RAM and pool of CPU, and they can grow and shrink as they need. And that's a small way of sort of on-premise way of looking at elasticity. Of course, when you get into cloud computing, you'll learn that can expand across multiple machines across the board in these big data centers, but not to get into that just yet here. But that's the idea. Hopefully that now helps you with understanding that concept of what virtualization is, and with that is really where cloud computing started to come into play, which I'm not explaining in this video. But hopefully now you have a much better understanding of the concept of the RAS, VPN, as well the DMZ concepts and virtualization. And now in this next section we'll start getting into the concept of cloud services. Now, with the creation of virtualization, this got companies thinking, if we can emulate hardware, we can create these virtual machines, and we can store software on there. We can have operating systems running on that emulated hardware, the operating systems being called guest operating systems. We could technically host these virtual machines for companies for a price as a service. So the idea being, hey, you pay us a fee each month and we'll host your virtual servers, and you don't have to deal with all the headaches of hosting your own data center on premise, and the power that's needed to do that, and the air conditioning that's needed to do that, all the hardware that's needed to do that, as well as the knowledge of how all the hardware works. So this is essentially what a cloud company brings to the table. So various companies like Google and IBM and Microsoft and Apple and all these companies, a lot of them already had tons of data centers, these big massive warehouses all over the world that they could support it. Some of these companies, such as Microsoft and IBM and Amazon, and Amazon being one of the biggest and first, decided to open this up to the public for a fee and allow you to host your services in their data centers. So this is where cloud computing really comes into place. This big cloud here is going to represent cloud computing, mainly the Microsoft cloud computing. And of course, it's all connected to the internet with incredibly fast, high-speed internet connections, fiber connections, and all of that. So there's some terminology or some acronyms I want to talk a little bit about real fast here as we get into this. First off, in cloud computing, there is an acronym we call IaaS. That stands for Infrastructure as a Service. Okay? Infrastructure as a service means that a provider is hosting all of the hardware infrastructure for you, and then they are going to provide you with a way for you to interact with that hardware and utilize their hardware as a service. All right, and this, of course, is where Azure comes into play, Microsoft Azure. Now, you might pronounce that word different. People have different ways of saying Azure. Some people call it Azure, some people call it Azure, some people call it, I've even heard it called Azure before, Azure. There's various names for it. In fact, years ago when I was first learning Azure, I decided I wanted to make sure I was pronouncing this correctly. So I was like, I'm going to go to watch the developers. So I started watching videos of the developers, the people who created Azure, and I figured I would determine. The very first video I ever watched, the guy was pronouncing the word Azure, so that's how I say it. But what I further learned is that the Microsoft developers don't agree on how to say it either. Some of them say Azure, some of them call it Azure, some of them call it Azure. So anyway, tomato, tomato, pronounce it however you want to pronounce it, okay? But Azure is Microsoft's main IaaS system. What this is Microsoft is going to host, they've got all these data centers all over the world, and they're going to host their hardware so that you can host on top of their hardware your virtual machines or whatever it is. So you can host virtual machines. Microsoft will also allow you to have access to what are called virtual appliances, like virtual firewalls, also virtual load balancing software, because you can get access to what are called VNets, This is virtual networking, so you can create these virtual networks based on TCP/IP that are running your, in their cloud service with virtual machines on it, and then you can put a virtual firewall. So you can almost like recreate what you're seeing here in an on-premise environment. You can recreate that in the cloud. They also provide virtual storage, so you can store data and backup data out there. They support database hosting, all of that. That's all part of IaaS. Now with IaaS, the model for that, for the most part, is you pay for what you use. So there's an algorithm that looks at how much memory, how much processing power, how much storage that's being used, and then you get a fee each month for what you're using. The good news is they do have a calculator that kind of helps you forecast this, and you can even set alarms to let you know if you're approaching a certain budget that you've got on cost. There's a lot of things out there to help you do that. But that's the idea. You pay for what you use. Okay, now there is another couple of terms I want to mention as well. This next term is called platform as a service, and then there's a third term called software as a service. So platform as a service, PaaS, and software as a service. Platform as a service and software. Let me explain software as a service first, because it's pretty easy to visualize, and then I'll explain platform as a service. So the idea of software as a service is basically they have applications that can be hosted in the cloud service, apps, if you will. These apps are 100% ready to use, ready for you to take advantage of. All you got to do is use those applications. Okay? For example, Microsoft has what's called Office for the web, or it used to be called Office Online. So that's like Microsoft Word, Excel, PowerPoint. You can run it from within your web browser. All you got to do is just jump right in and use it. So from an admin standpoint, all we have to do is assign the users that are allowed to use that, and they can go use it, and it's available to them 100%. All they got to do is start using it. There's not really a lot of administration for us. Now, what is platform as a service? Well, platform as a service is a system in which the majority of the configuration is done for us, but we still have some admin configuration we have to do to use it. For example, with virtual machines, this is 100% IaaS. A virtual machine you can put whatever operating system on there, but you're responsible for the operating system. You're responsible for the software that goes on it. You as an admin have to manage all that. Okay. With platform as a service, virtual machines are set up in the background that you don't have any control over. They've already put the operating system on there. They've already put the software on there. You don't have any control over any of that. But there's still some administration you have to do in order to control it. For example, Microsoft has a directory service called Azure AD. Now, this is a big deal. This is probably one of the biggest deals of the things I've gone over so far in this cloud. Azure Active Directory is what we call a platform as a service. It is a directory service that is sort of the cloud version of what you have here called ADDS. So now I remember when I first heard about Azure Active Directory, I thought, oh, well, this is just like you're just hosting virtual domain controllers in the cloud. No, they have completely redone the concepts of Active Directory. It is completely redone with all new web-based programming languages. It does not use any of the dated stuff like LDAP and Kerberos and all that. It uses industry standard authentication protocols in order to support all the latest and greatest features and capabilities in the cloud. Okay, and so these are where users, passwords, all of that stuff is going to be managed in the cloud. But it starts out with almost nothing in it. So it's ready to use, but you as an admin have to start creating users and all of that. Now you might say, well, wait a minute, what if I want to use my on-premise users in the cloud? Well, stand by, I'll explain that in a second. Anyway, Azure AD is a platform as a service. So is, here's another one, Exchange Online. Microsoft has Exchange Online. That is actually both a platform as a service and a software as a service, in that the admin side of it is the platform as a service, but the user side is the software as a service. Same thing for SharePoint Online. Microsoft has SharePoint Online as well. Same idea there. All right. And then you've got Microsoft Teams. That's the admin side of that is a platform as a service, but the user side of that is a software as a service. There is OneDrive for Business. That's a cloud storage that we have access to that allows users to store their data out there in the cloud. There is a product called Intune, which is Microsoft's MDM product. MDM, it's also MAM product, so it's both. Mobile device management, that allows us to manage devices. This is one of the most powerful things we have available to us. This is what sort of is replacing the concept of GPOs. This is going to allow us to manage our device settings. Not only can we manage on-premise devices, but we can manage mobile devices. GPOs can only manage devices for Windows. With Intune, we can manage Windows, Android, iOS, iPadOS, macOS, all that stuff. With the help of Intune, we can manage the settings and restrictions. We can deploy software. This is a very, very powerful product, okay, that we have available to us. It even has a thing called autopilot, which will allow us to reconfigure Windows machines and all of that. So very, very powerful stuff that we have available to us. All right. Now, I will tell you that Azure has, Azure definitely has some of the, it has some platform as a service technologies and some software as a services technologies, but the main type of system that Microsoft has created for platform as a service and software as a service is called Microsoft 365. Okay, Microsoft 365. All right, which I forgot to add to my display here. We actually do have apps that are called the Microsoft 365 apps. All right, which formerly they would call them Office 365 apps. They're now, starting to call them Microsoft 365 apps. But the Microsoft 365 services is a cloud service that basically sits on top of Azure. So you have Azure in the background of all this, and the Microsoft 365 sitting on top of it. All right, you can't have a Microsoft 365 account or tenant that doesn't also have Azure. Azure is in the background no matter what. And the other thing to be aware of is both of these share Azure AD. So you'll notice that there are web portals for creating users and things through Microsoft 365 or creating users through Azure. It all ties back to Azure AD. You're going to see the same users no matter what. So these two things are glued together basically. Okay, they're glued together. Now on Microsoft 365 with PaaS and SaaS and all that, you're not really going to be hosting virtual machines, but you're going to be working with these services. Let's just kind of color code some of this real quick. All right. Now again, I do want to add that Azure does have PaaS and SaaS services that I'm not getting into right now, but it's mainly an IaaS based service. That's its main focus. Microsoft 365 is strictly PaaS related and software as a service, SaaS related. It doesn't really have any virtual machines or any of that, though it can interact with them. Okay, so if I was to sort of draw a circle around some of these, all of this stuff you see here would be Azure related, and then all of this stuff you see right here would be the Microsoft 365 related. Now, they both share Azure AD, so I'm going to put a purple circle around that. Red and blue make purple. All right, and so they all link to that. Okay, and so that is how Microsoft handles those concepts. The other thing about With Azure, you're paying for the CPU, RAM, storage you use. With Microsoft 365, it's all based on licenses. So you purchase these subscriptions that have a certain amount of licenses, and you issue these licenses out to your users, and your users can take advantage of these various features. Okay. One more thing I want to explain here, and that is, what about the issue of what if we want to use our on-premise users to access resources in Azure? Well, Microsoft has a solution for that. They actually have a type of server that you can set up, and the server is called an Azure AD Connect server. Azure AD Connect. Now, what does this do? An Azure AD Connect server, this is a synchronization-based system, and what it will do is it will allow my on-premise users to be synchronized out to Azure AD. Now, it does not allow Azure AD users to be synced in, only out. But it will allow user passwords and all of that to be synced in. So if a user is logging on to Azure AD and they change their password out in the cloud, it does have the ability to synchronize that password back in. But the beauty of this is by going this route, if you have this on-premise environment, you can achieve what we call SSO. What is SSO? Single sign-on. The idea of single sign-on with all of this is my user can sit down at their on-premise computer, they can log on, and it's going to log them on both in the cloud as well, it's going to log them on-premise as well as in the cloud at the same time. All right, and they can access resources out there. The other thing I'll tell you is that Microsoft has moved into a way to where you could technically not even have a domain nowadays. You don't necessarily have to have a domain. In fact, it pains me to say this as a consultant because, I have fed my family for, 2 decades by using Active Directory, both teaching it as well as, consulting on it. But I'll be honest, Microsoft is now moving in a direction to where domains are not even needed anymore. They're now making it possible to where everything can be managed through your cloud service and domains are not needed. But if you're a company that's already got a domain and all this is still in place and all of that, then this Azure AD Connect server is going to be the thing that's going to help you. Okay? All right. Well, hopefully this has now helped you have a better understanding. This was really just a fundamentals video to help you understand the cloud service, the concepts of it, and I hope that this has been helpful to you. Now, the first thing I want to say in regards to Azure and virtual networks is that if you have an understanding of just how physical networking works, even in like a traditional on-premise environment where you have to have what are called subnets, and you're running a TCP/IP based network. Granted, it's still to this day, even though we do have TCP/IP version 6 out there, the majority of everything that's running is still TCP/IP version 4, which is what Azure is running and kind of what we're focused on here. Your virtual networking concept is very, very much like on-premise networking. So the same kind of concepts that you have learned and used in the on-premise side of things in regards to TCP/IP is pretty much what you're going to find is running in Azure. All right. Now, when you start using resources, there are all sorts of types of resources out there that communicate and work on a virtual network, or VNet as it's called. All right. Of course, virtual machines are going to have VNICs, and those VNICs are going to interact. Virtual Network Interface cards is what that stands for. They're going to interact on the virtual networks. All right. Now, the virtual network is within Azure, within their Azure networking space, and it's able to route traffic across that virtual network and communicate with the internet if you attach public IP addresses and all of that. And the virtual networks even have a DHCP service, a Dynamic Host Configuration Protocol service, that will issue out the addresses that you set up in the address space that you have. So what I want to do now, I want to draw some of this out and help you visualize it before jumping in and using it. Okay, so we'll start by setting up a VNet in this graphic. Now, the VNet is going to represent a network as a whole, all right? And we'll say that this rectangle is going to represent the VNet as a whole. A VNet is going to be made up of an address space. All right, an entire range of addresses that make up the whole virtual network. All right, so I might call this VNet. We'll call it VNet A. All right, let me lower the font down just a little bit here because it's taking up a little bit too much room, but we'll call this VNet A. All right, so let's see. There we go. And basically VNet A, the address space will be, let's say, from, we'll say 10.1.00/16. Now, I'm not here to teach you TCP/IP. You kind of have to have a little bit of an understanding of TCP/IP coming into this, but that if you do the math on that in TCP/IP, there's basically 65,000 addresses that would be available within this address space. Okay, this is a very common type of address space in a private network that you use. The /16 means that this would have a subnet mask of 255.255.0.0. Okay, and that would make up basically 65,000. There'd be a total of 65,536 addresses. You have to really subtract a couple there, but roughly 65,000 addresses. However, we're not going to need 65,000 addresses on all of our given subnets, because ultimately, here's the thing: you have your virtual network, which is this square as a whole, but then you have to set up what are called subnets. Just like in traditional TCP/IP networks, you have the network as a whole that might represent the whole network, and then you might have subnets that go inside that network. Okay, so from there, I might have, let's say this right here will represent, this is going to represent a subnet. And we'll call this subnet A. All right. And so from there, it might be 10.1.1.0/24. Okay. So you're slicing off a piece of that 65,000 chunk of addresses by doing that. You're basically saying that you're going to roughly have 256 addresses. Actually, in TCP/IP, you probably know this. If you know TCP/IP, you have to subtract 2. You can't use the very first address on an addressing system, and you can't use the very last address. The very first address represents what is called the network address in TCP/IP, and the very last address is what we call the broadcast address. So in reality, you would have a range of addresses that would be available: 10.1.1.1 to 10.1.1.254. Now, Azure also does reserve a couple of other addresses for itself, but I'm not going to get into that right now. That would be your actual range that would be available. So the virtual machines and all that go on this virtual network would be able to take those addresses, and you'd have a DHCP service that would handle this for each service, each subnet automatically. All right. So then I might have another subnet over here. Let's create another subnet, and we'll call this subnet B. All right. And then maybe subnet B is going to be 10.1.2.0/24, which means you would have a range of 10.1.2.1 to 10.1.2.254. That would be your range, all right, of addresses that are available on that subnet. Okay. And then, of course, let's say you want to have another subnet. We'll say subnet C over here. Each subnet could contain different virtual machines, and you could be putting them on different subnets for that purpose. One of the reasons for putting things on different subnets and not just doing one big subnet is that you could have security rules and stuff for that specific subnet if you want. But not getting into the IP filtering just yet. So then subnet C might be 10.1.3.0/24. Hopefully you're seeing a pattern here, and you would basically have a 10.1.3.1 to 10.1.3.254, and that would be your range. So again, you can put your different virtual machines on these subnets, and from there they would be able to communicate. One of the interesting things about having subnets in the same VNet is that they can automatically talk to each other. So for example, if you had a virtual machine here, we'll say this is a VM, and of course virtual machines have VNICs. A VNIC is going to be the object that represents the adapter card for that virtual machine. That VNIC would automatically get an address from the DHCP service that the VNet uses. Okay, and then if I had another virtual machine down here and maybe another virtual machine over here, all of these could talk to each other automatically. They could automatically communicate. They could automatically talk to each other, and traffic could flow between those different subnets. That's automatic. Now there is this thing that is called an NSG. An NSG is called a network security group. NSG. All right, I'm going to put a little square around it. NSGs are IP filtering capabilities. And what they basically do is they can restrict traffic from flowing to one place to the other if we want. NSGs can be placed either directly on a VNIC, or they can be placed on a subnet as a whole. So for example, if I had some kind of VM here and I really needed to lock down what could talk to it, maybe I want the virtual machine in subnet A to talk to this VM, but not the one in subnet B. I could actually do that by using NSG. I could place the NSG on the whole subnet and restrict this VM from talking to the whole subnet, or I could just place it on this VNIC and restrict this guy from talking to this VNIC. And of course that can include things coming from the internet and all of that stuff as well. All right, because of course that is the other thing that I'm not looking at just yet, but you can assign public IP addresses to all this too, and you can allow things from the internet to get in. In this case right now, since I don't have any kind of public IP address, there's nothing that's actually talking from the internet to these machines. All right, these machines can actually go out to the internet if you want them to, but things can't flow in from the internet. All right, so kind of summarizing what we're seeing here, we've got a VNet called VNet A, and we've only got one VNet, and we've set the whole entire range, which is 10.1.00. Now, if you were to actually think about that whole range, you would have 10.1.0.1 generally up to 10.1.255.254. That would be the full range, the full 65,000 range. And what these subnets are doing is they're breaking these up into smaller chunks, smaller, more manageable chunks. The general rule of thumb, most people kind of go by this. You don't have to go by this, but the general rule of thumb is your subnet should be /24 based. That's 255.255.255.0 on the subnet mask, which gives you roughly 254 addresses, even though Azure does reserve a few more than that. You get roughly 250 when it's all said and done, okay? Depending upon what Azure reserves for itself for routing traffic. All right, but again, all of these subnets by default will be able to communicate with each other because they're part of the same VNet, and the NSG could be used to restrict that. Now, don't think of an NSG as a firewall. It is an IP filtering system, which is something firewalls can do. But Microsoft actually has a thing called the Azure firewall that handles the more intense stuff in regards to securing things. All right, now. This is just looking at this from the perspective of a single VNet. All right. Now, in your enterprise, you might have multiple VNets that are associated with different projects and things like that you're working on. So what I want to do now is I want to look at this from the perspective of not just one VNet, but multiple VNets. All right, so looking at this from a larger standpoint here, imagine you've got multiple VNets that you're working with. Maybe you've got different projects going on, and each project is dealing with its own VNet. There's various things you could do here, but so we'll do this. We'll say that this represents our first VNet here. All right, we'll call this, instead of VNet A, we're going to call them VNet. We'll do VNet 1, 2, 3, so on and so forth. Okay, so VNet 1, and we'll say that the range is going to be put the range up here for this. 10.1.00/16. All right, and then let's do, we'll say VNet 2, and the range will be the 10.2.00/16. All right, and we'll do, make that a little bit smaller because I want to fit one more in there. VNet 3 is going to be 10.3.00/16. And then we'll do one more over here. Try to fit that in. And that will be VNet 4. All right, 10.4.00/16. And we'll just kind of center this stuff a little bit better. Move this over a little. Move this out here a little bit. Okay, now this is actually a pretty common scenario too, where you might have what is known as a hub and spoke scenario. A hub and spoke scenario might be where you've got, you know, one main VNet where sort of is the hub where everything comes in, and then different spoke VNets that are interacting with that hub VNet. All right, and so of course now you've also got to consider you've got some subnets that can fit onto this, right? So maybe we've got, let's do this. We'll say this. This is going to be, we'll call this subnet 1A, and maybe the range for that would be 10.1.1.0/24. And then maybe we've got another subnet over here. And we'll say this is subnet 1B. And this will be 10.1.2.0/24. So we're just slicing this up into chunks of 254, roughly 250, when it's all said and done, from this full range here. And then of course you can do the same thing on these subnets over here. You could have you know, subnet 2A, and this would be 10.2.1.0. You can use the 10.2.0 subnet as well, but I like to do it that way. I like to use the 1 because it's the first letter of the alphabet if I'm naming this. But so then we could do another here. All right, we'll say subnet 2B, and that would be 10.2.2.0. You see the pattern, I'd imagine, at this point. And then over here, let's just keep it simple. Let's just give each one of these, we'll just give them one subnet. All right, so then we'll say this is going to be subnet 3A, and that'll be 10.3.1.0/24. And then we'll do the same thing over here. We'll just keep it simple and give it one subnet, and it'll be subnet 4A, and then that would be 10.4.1.0/24. Okay, so this is my strategy. Now, the other thing I want to clarify is that you have to consider the fact that you may at some point connect your on-premise network with Azure, and you got to make sure the addressing system that you're using in Azure does not conflict with the addressing system that you're using on-premise. That's very important. It's a huge pain if you've got conflicts. So if you're using this addressing system on your internal network, you don't want to be using that in Azure. You want to use something different. This is why we use the 10, because a lot of companies are using the 192.168 or the 172.16 strategy on their on-premise network. All right, so just think about that. All right, now the other thing I want to point out here is that that even though you know, these subnets can talk to each other, and these two subnets can talk to each other. Essentially, none of the subnets can cross VNets at this time. So, unfortunately, the thing you got to understand about all of this is that when you have separate VNets, they don't automatically have routing between them. Okay, like up here, these subnets are all part of the same VNet. They've automatically got what is known as system routing enabled. And so they automatically can route traffic between these different subnets. But down here, we don't have that automatically. Okay, so there is a way to handle that, and it's a thing called peering. All right, peering allows traffic to flow between the different VNets. All right, so I can actually create this thing called a peering. And peering actually happens from both sides here. That's why I'm drawing these two little arrows. If I want, and this is traditional. If you're doing a hub and spoke type scenario, you would do it this way. Instead of connecting them all together, I'm going to make everything travel through the hub. Now, in the hub VNet, what I might do is I might have what's called the Azure firewall, and the Azure firewall can basically police traffic flowing between the VNets. All right. Now, keep in mind, you can still have NSGs, which will do IP filtering and all of that. But the NSG is not a full-blown firewall. It just does what's called packet filtering. If you want to police things, maybe you've got, here's the internet right here. All right. Let me just kind of get rid of the little thought bubble thing here that it puts on there. But let's say this is the internet, okay? And you're trying to allow traffic to flow, from the internet into your Azure environment, which you very well can do. You can set up a public IP address and all that. You might set up a Azure firewall. All right, we'll say Azure firewall right here. This is what we call a virtual appliance, and it might be hooked into that subnet, and you might have a PIP, a public IP address, coming in here. And what happens is traffic trying to flow to any of these other subnets. Maybe you've got some virtual machines. Let's just copy this just to keep it simple. Maybe you got a virtual machine here, and you got a virtual machine over here. Maybe you got this is a web server or something like that, and you're having to police traffic flowing in. Everything would have to flow through this Azure firewall before it could get to any of these VMs. And same thing, if you wanted to allow these various virtual machines to communicate with each other, maybe you're going to allow this guy to communicate with this guy over here. You can make it where everything's got to go through this firewall. So Azure, once you set your peerings up, and let me just kind of clarify in my diagram that that's what those lines are real quick. All right. So this is a peering, right? This is a peering, and this is a peering. Once you've set that up, you've got two peerings really, because it's a send and receive. You can actually make it where you can send traffic from a VNet to another VNet, but you can't receive traffic. That's something else you can do. But in this case, I'm allowing traffic to flow both ways. But anyway, I can use these things called UDRs, which is called a user-defined route. Okay, a user-defined route, UDR, user-defined route. This will allow me to direct traffic and force traffic to go through something if I want. In other words, I can make it where, any of these guys right here, any of these subnets want to talk to each other, they have to flow through the Azure firewall. I can use this thing called a user-defined route to control that traffic. All right, if I want. So maybe I've got, I've got virtual machines on each one of these subnets here. All right. Ooh, just barely fit, but it did fit. And I can require everything to have to go through that Azure firewall if I want. The other thing I can have is I can have load balancers and everything else. You can have you can do what is known as virtual load balancing, which is really neat. And you could maybe, if you were in a situation where you had a web server here and a web server here and a web server here, and you wanted a load balance between those three, you could do that. All right. And then finally, again, talking about our on-premise network, this triangle is going to represent your on-premise network. Maybe your company has a Microsoft domain, and the symbol of a triangle is always going to represent a domain. All right. So this is what we call ADDS, Active Directory Domain Services, and that is on-premise. All right. we have various ways that we can actually connect an on-premise network into Azure. One of the things we can do is we can do this thing called a VPN gateway. All right, a VPN gateway, VPN GW here. A VPN gateway is another type of appliance that we can have. All right, and it can establish a connection with an on-premise domain. So traffic can flow securely into this VPN gateway. And really what's happening, just to give you a better look at it, is it's really, you would have to have a what's called a VPN concentrator. And that VPN concentrator would be on-premise. Let's make it orange. It would be on-premise, right? And this VPN concentrator could establish a internet connection, and then from that internet connection, you could connect it into this VPN gateway. And from there, traffic can flow from on-premise directly into your subnets if you want. There's another solution that will connect everything together called ExpressRoute. So again, this is called ExpressRoute. Some people will call it a direct route or a direct connection into Azure. But what you basically do is you work with a telecommunication provider and they install hardware at your office. And what that basically does is it uses the telecommunication private network and connect directly into Azure that way. So you can use a VPN concentrator to do what's called a VPN gateway and connect into Azure. It uses the internet, so it's virtually private, or you can use a direct connection from your on-premise environment into the cloud as well. So those, and of course that's going to be the more expensive route to go, but you have a private connection through the telecommunications provider with Azure, and you can have insanely from speeds of 10 gigabits per second up to 100 gigabits per second in certain regions, if you spend the money. Of course, again, you're talking some serious money when you start getting into that. All right. So hopefully these drawings, I know this is a bit of a mess, but hopefully this drawing gives you a better, at least a visualization now of kind of how all this sort of works together. I know I haven't really explained doing any of this yet through Azure, but now at least you can kind of visualize it before jumping in and doing it. I'm now going to go through the process of creating some VNets, and I'm going to set this up in a hub and spoke style virtual network infrastructure. So here we are on portal.azure.com. Going to click the menu button and go down here to virtual networks. Just remember, if whenever you do this, if you don't have virtual networks, you can always go to all services, just do a search for virtual networks, and there it is. And I've added as a favorite by adding that little star symbol. So I'm going to click on virtual networks. I'm going to click to create a virtual network, and I'm going to create a resource group called demo RG, okay, which is just going to be short for demo resource group. And then I'm going to name this VNet. I'm going to call it VNet1-hub, just to kind of indicate this is going to be my hub. And then we're going to put this in the East US region. I'm going to click next. And I'm not going to go with this default addressing system, address space. I'm going to actually set this to 10.1.0.0/16. And as far as a subnet goes, I'm going to add a subnet. I'm just going to call this subnet 1A, and we'll make it 10.1.1.0/24, which is going to fall within that range. So I'm going to click add. All right, for now, I'm not going to create any more subnets there. I'm just going to click review and create. Waiting on it to validate, and we're going to go ahead and click to create. All right, so now that is in the process of creating that VNet. All right, as you can see, we can click go to resource, and the VNet is created, and our address space is there, subnet is there. Now what I want to do is I'm going to create a couple more VNets. So I'm going to go back over here to all services, do a search for VNets for virtual networks, or I can just click menu and go to virtual networks. So there's our first one. We're just going to create another one. I'm going to store it in the same resource group, demo RG, and I'm going to call this one VNet2 and I'm just going to put the word spoke on there, just to indicate that it is a spoke. All right, we're going to click next, and the addressing system will be 10.2.0.0/16. We'll create a subnet of, we'll call it subnet 2A. All right, and that's going to be 10.2.1.0/24. All right, that'll fall within that range. We'll click Review and Create. Okay, we're going to click to create again. All right, I'm going to click the menu button, and I'm going to go ahead and move over to Virtual Networks because I'm going to create two more VNets, two more spoke VNets. So we'll click Create. Demo RG. We'll call this VNet 3, and I'm going to put the word -spoke on there just to indicate that it's a spoke. We'll click Next. We're going to change this to 10.300/16. Hopefully you can see a pattern going here. And then this will be subnet 3A. All right. 10.3.1.0/24 will be our subnet. We'll click Add. We'll click Review and Create. And create. All right, we're going to create one more. Click the menu button here, go to Virtual Networks. You will notice it does take these a little bit of time to show up. All right, so we'll click to create. Store this in Demo RG. Call this VNet 4-spoke. All right. Click Next. The addressing system will be 10.400/16. We're going to click Add a subnet, and this will be subnet, we'll call this subnet 4A. Okay, 4A. And that'll be 10.4.1.0/24. We'll click Add. We'll click Review and Create. Click to create. All right, and we've now created, after this deployment finishes, we've now created our 4 virtual networks. So we should be able to click Virtual Networks, not virtual machines, but virtual networks, and we should see that all 4 of these are created. Now keep in mind, these VNets cannot talk to each other at the moment. This is because we haven't done what's called peering. So right now, if you were to put virtual machines on these virtual networks, those virtual machines would not have communication with each other. But that's okay, because that's not what we're really looking at right now. In this video, I just wanted to demonstrate creating the 4 VNets. Each VNet has one subnet. As you can see, that's subnet 1A, which is on the hub VNet, and then we go to the other one. Subnet 2A falls on VNet 2, the spoke. Subnet 3A falls on VNet 3 spoke, and then subnet 4A falls on the VNet 4 spoke. All right, so we've now got our 4 VNets, and that's all I wanted to do in this particular video. I'd now like to peer my virtual network. So here I am on portal.azure.com, and click the menu button here, and I'm going to go to Virtual Networks, which again, if I don't have virtual networks, I can always go to All Services and search for that. Okay, from there, I'm just going to go to the hub. All right, and we're going to scroll down here to peerings, and we're going to click Add, and I'm just going to set up my peerings between it. So we're going to say hub to spoke 1. All right. So I'm going to allow traffic to remote virtual network and allow forwarded from the remote network. This is not for a gateway. And then the peering, remember that the point of peerings is to allow traffic to pass between VNets. Remember, traffic can always pass between subnets that are part of the same VNet. But by default, traffic cannot pass between VNets. So we're going to fix that by adding these peerings. But remember, peerings are a two-way street. You have peering traffic flowing in two different, a direction to go somewhere and a direction coming back from that location. So we got hub to spoke 1, and we're going to say spoke 1 to hub. All right, and from there we're going to select the spoke, spoke 2, VNet 2 spoke of, yeah. So we'll say, let's just change the name to VNet to spoke. That was the naming convention I gave it. VNet to spoke. There we go. So we'll select VNet spoke, VNet to spoke. Same rules here, allow and allow. We'll click add, and that's going to create that first peering. Let's create the next peering. This is going to be hub to VNet 3 spoke. Allow. We'll say VNet 3 spoke to hub. All right. We'll select VNet 3, and then we'll click add. So that's going to add the second one. And then we're going to go ahead now and click add again. And we'll say hub to VNet 4 spoke. All right. Allow. VNet 4 spoke dash to hub. And then we're going to select VNet 4. So we'll click add. All right. And at that point, we've now set up our peerings. You will notice the status of the peering does take a moment to update. So you do kind of have to be a little bit patient here and give it time. Until that says connected, no traffic can really pass between those VNets. Okay. So all are set up now. So we've got peerings going in both directions. Right now we're looking at the hub. If we go, for example, over to VNet 2 and we click on peerings, we can see the VNet 2 to the hub. So we've got it going there, we got it going back, and that's going to help us with making sure we've got our peerings set up. I'd like to now go over the concepts of dealing with certain resources in Azure. Now, there are going to be certain resources that you try to add to a virtual network that require special subnets, okay? For example, a VPN gateway, Express Route Gateway, Azure Firewall, these are various services that will require their own virtual network subnet. I'm not saying you have to create a whole new virtual network, but you do have to have a VNet subnet, a subnet dedicated to that particular resource. Let me show you what I mean. Here I am on portal.azure.com. All right, I'm just clicking the menu button, going to all services. Let's try adding a VPN gateway. Now, I do want to point out this is not the lesson where I explain VPN gateways. I just want to show you how when I try to create a VPN gateway, it's gonna force me to create a subnet. Okay, so if I go right here, let's see, virtual network gateway. If we click that, click to create a virtual network gateway. All right, I'm going to choose my resource, or choose East US, and doesn't really matter what I name it right now. Okay, so look, if I choose VPN as my gateway type, I'm going to select, let's say I want to put this in the hub VNet, which traditionally, that's in most cases, that's where that would go. It would go in the hub VNet. All right, notice that it's going to force me to create a subnet range. Now watch what happens if I try to use one of my existing subnets. I have an existing subnet, which is 10.1.1, and it'll tell you the specified address space overlaps with subnet 1A, which has a range. So it won't let me do that. Okay, it'll let me do 10.1.2 because nothing's there, or 10.1.0 because nothing's there, but I can't use an existing subnet. Okay, same thing with Express Route. If I try to do an Express Route gateway, I'm going to have the same issue. Okay. Notice it overlaps. So that's an example of a service that's going to require its own subnet. The good news is you could create the subnet ahead of time, or it's okay, it'll do it for you when you're creating the resource. So it's not one of those things where you got to actually leave out of this creation and create the subnet first and come back into it. All right, now let's look at, let's say we wanted to create a application gateway. All right, instead of a VPN gateway, with application gateway. An application gateway is actually a level 7 load balancer, layer 7 load balancer. Again, not getting into the details of this in this particular video, but if I go to create an app gateway, all right, let's go resource group. Let's do East US. Okay. We'll scroll down and notice I have to select a virtual network. So if we do hub, but here's the beautiful thing. application gateways can share a subnet that has existing resources on it. So an app gateway is an example of a resource that doesn't have an issue. Most of the resources in Azure can sit on subnets with other resources. It's just certain resources that cannot. For a good example being a VPN gateway, express route gateway. Application gateways are fine. Okay. How about the Azure load balancer? I'm sorry, Azure firewall. If I go here back to all services and I put in Azure firewall, all right. So let's go right here to firewalls. Click create. And again, I know I sound like a broken record. This is not the video where I explain firewalls. Okay. But if we go here, all right, let's make sure we select East US. All right. And then go down here. Okay. So look, I'm going to try to use an existing virtual network. All right. I'm going to try hub. Look at Azure firewall cannot be used with a from different resource group. All right. I love the Azure firewall cannot be used with a from a different resource group. So they got some issues with grammar there, but that's okay. All right. But you'll notice that in this case, Azure firewall can't be used. This virtual network, it's not going to let me use this because it's going to require me to have a specific subnet just for the Azure firewall. In fact, if we do a quick search, let's do a quick search on Google, Azure firewall subnet. This will bring us to a Microsoft article. Deploy the Azure firewall. Here I am searching in Google. Okay. So if we go do that, look, you have to have a subnet called the Azure firewall subnet before you can go in there. Now, I'm not real sure why Microsoft does it that way on this. It's kind of glitchy to me. I feel like they could have allowed the creation wizard to let you go ahead and do that inside the resource wizard, but they don't. So you'd have to create the subnet ahead of time and then jump back in and go from there. So my point in that is some resources are going to require, the majority of the resources are going to be fine. They're going to share subnets on a VNet, no problem with other resources. Some resources, such as the VPN gateway, express route gateway, and all that, will require a special subnet, but it'll create the subnet for you in the resource creation. And then the Azure firewall is an example of a resource in which you have to create the subnet ahead of time before you come in there. All right. So hopefully that kind of helps you wrap your head around that. Again, not really a video where I'm creating those resources or creating any more subnets in this video. I just wanted to explain that concept. Certain resources do require their own subnet and have different rules for creating that subnet. I'd like to now go over the concept of a feature in Azure called subnet delegation. Now, this is the official document that Microsoft puts out on this, and you can very easily find this by going to Google or Bing and just searching for what is subnet delegation. Ultimately, this is a great little feature. It's very easy to set up, and the concept of this involves being able to take a subnet and delegate it to a specific type of service in Azure. Now, the reason this is important is because certain services in Azure need to be able to place their own rules and policies on that subnet. They need control of that subnet, and they need to be able to place rules on that. So that's the idea. As you can see, there are some advantages here. Helps to designate a subnet for one or more Azure services. Allows the injection of rules and policies. When you do this, it can associate its own NSG, its security policies, route policies get placed on it. And what it does not do, as they tell you here, is the Azure service can inject instances into customer subnets, but not impact the existing workload. So they can't change any services that are already sitting on that subnet, although the rules they place on the subnet could affect those services. Also, they tell you the policies or routes that these services apply are flexible and can be overridden by the customer, so you can make some changes to it. Okay, but it is actually very easy to set this up. It just takes a few seconds. All right. So let me give you an example. Jumping back to portal.azure.com, if I click the menu button here and go to all services, I can do a search for virtual networks, right? Or of course you can always just click the menu button and go there if you've got it as a favorite. Click on the virtual network you want. In my case, maybe the hub. And then I would go here, maybe create to the subnet blade. Click create the subnet up here. And then I'll give it a name, subnet 1B. And then I'm going to say Nginx. All right. Because maybe, again, I am going to host a web app that's running the Nginx web service, and I'm going to associate that with this. And this is just kind of a way to give me a little bit of a description. So if I'm looking at this subnet later, I know that Nginx is associated with this. So from there, we'll set the subnet address range to 10.1.2 because the 1A subnet is 10.1.1. And we're going to go down here towards the bottom. And right here, this is where the magic happens. I can drop that down and then scroll down, and I would find, so you can see all these different services that can be delegated. And there is the Nginx deployments right there. So I'm going to select that one. All right, and then I'm going to click Save. And at that point, it is now going to delegate that subnet to the Nginx service. Now in this video, I'm not really getting into the full-blown associating web apps and all that. I'll give you the gist of it though. From there, I would go to the menu button, I would go to all services, all right, and then I would do search for like app service, okay, and I could add an app service, click to create. This is going to be maybe the Nginx app service I want to deploy. Okay, give it a name. I'll just say app service 1. We'll say Docker container Linux, and then I would say East US, right? And we would click next, and there it is. We would choose Nginx, okay. And we could say network injection. We could choose the subnet. Okay, I'm not going to go any further. I'm not going to do the full thing right now. I'm not really getting into hosting web apps. I was just kind of pointing out the gist of it. But hopefully that helps you now understand the concept of subnet delegation in Azure. Now, one of the things that's pretty common in Azure is the various services that you work with require a public IP address. Some of the different services that you work with require multiple public IP addresses. So one of the things that Azure does allow you to do is set up what's known as a public IP prefix, which is essentially a group of public IP addresses that are statically associated in Azure and can be issued out for various services that you use. For example, if you had a group of virtual machines that needed an IP address, you could use one or more of your groups of IP addresses for that, or maybe an Azure scale set for scaling out multiple virtual machines. Another example would be load balancers, Azure firewalls, VPN gateways, NAT gateways. So there's lots of different services that are going to utilize these public addresses, and so this is a way for you to reserve specific public IP addresses in Azure. Okay, you can even associate your own customer-owned public addresses into Azure as well, as opposed to using the ones that are built into Microsoft or owned by Microsoft. Okay, so let me show you how we can go about doing this. Here we are on portal.azure.com. Clicking the menu button, going to all services. Now I'm just going to type in the word prefix, and you'll see public IP prefix right here. So I'm going to click on that. Click to create a public IP prefix, and then from there we'll choose this demo RG resource group that I've created earlier, and I will give this a name. I'm just going to call this public prefix demo for lack of a better name. East US will be my region, IPv4. You can do v6, but most of the resources, almost every resource in Azure still really utilizes v4. And then it is Microsoft owned. Of course, there is the custom IP prefix. I'm not going to get into the details there right now, but it is possible to register your own IP addresses that you own through ISPs into Azure. But we'll go with Microsoft owned. Then you can choose how many of these you want. You can get them in group of 2, 4, 8, or 16. Okay, so I'm just going to go with 4. And then it asks you about zone redundancy, if you want high availability for in a situation where maybe a data center goes down at Microsoft, you're probably aware of the fact that in each region of the Microsoft data centers, there are 3 zones, which are essentially like data centers in each region. So, for example, in East US, there'll be 3 zones or 3 data centers that contain these resources, and I could pay extra to have a copy of this in all of the data centers. I'm going to choose one just to save on Azure credit. And then I'm going to click Review and Create, and we will click to create. All right, and I'm just going to wait on this to finish. All right, that only takes a few seconds, and then when it's done, we're just going to click Go to Resource, and you can see right here the addresses that we've been given. Now, to be honest with you, there's not, it isn't one of these things where this is a necessity, but one of the main benefits you get out of this is you're going to already know what the addresses are that you've reserved. And so as you create more Azure resources in the future, you will already kind of know what IP addresses that those new resources can be given. So again, that's going to be your main benefit to using this. This is not something that I would say is heavily used out there in the real world, but it can come in handy to already kind of know, hey, I've reserved these 4 addresses, and I know I've got to set up maybe 4 different Azure services. In the future, I've already got an idea mapped out of what the addresses are going to be that I'm going to use. All right. So that is the idea of utilizing this the public IP prefix in Azure. I'd like to now get into the concepts of choosing when to use your IP prefixes and what you can use it for. So here we are on portal.azure.com. All right, if we click the menu button, go to resource groups, I've created a resource group called DemoRG, and inside that DemoRG I have a public IP prefix right here called public prefix demo. And then you can see that I had used a /30 prefix, which is going to give me 4 addresses, and then I can add an address. But the question is, what am I going to use this for? So if I jump over and I do a quick Google or Bing search for the term public IP address prefix in Azure, you'll find this article. Okay. And they basically lay this out for you, and I just want to kind of go through this with you a little bit here real quick before doing much more hands-on. The first thing, of course, would be virtual machines. So one of the most common places you're going to want these prefixes would be for use in virtual machines. In a lot of organizations, when you're creating virtual machines, you want an IP address that you already know what these addresses are going to be, and you can post them in whatever order you want. So if you did, let's say, 16 addresses and you had to do 16 virtual machines, you would know exactly what order those static addresses are going to be in ahead of time, as opposed to just deploying them on the fly and getting some random address that Microsoft assigns you. So virtual machines being one of the main ones, associating your public address there. You can also do this with standard load balancers. Okay, you can associate a public address with that you've created. You can do the Azure firewall. This can also be used with outbound SNAT. So this would be the source network address translation and the use of static address for outbound. And so with static network address translation, I can have an IP address a specific address that I want to be used when the firewall is communicating with the internet outbound. All right. This is especially important if you are going to be routing maybe from your Azure firewall. Maybe it's going to route to your on-premise network and go out to the internet. That way, there could be rules in place there, and at least that way you're definitely going to know what the address is going to be ahead of time if you had to configure anything on premise in regards to that Azure firewall that's in the cloud. Another thing would be the VPN gateway. So your VPN gateways can utilize these public addresses. All right, if you had to deploy a couple of those, maybe one for each branch office, or maybe multiple. Let's say you had 5 branch offices, and each branch office is going to be associated with the different VPN gateway. You'll already know what those 5 addresses are ahead of time, and you can configure your on-premise VPN router to support that. Another thing would be virtual machine scale sets. Again, with virtual machine scale sets, that's a virtual machine basically that scales up when it needs to. So when a certain level of load is generated, like let's say maybe you have a virtual machine that's a web server, and the web server CPU gets to maybe 90%, you could have another virtual machine generated on the fly, and you can have these addresses associated with that. Okay. We've already mentioned kind of, utilizing load balancers, and then also NAT, network address translation gateways. So NAT gateways can also be utilized with a prefix. So just a standard NAT gateway, traffic flowing out to the internet, and then you can have public addresses that get associated coming in when something is being associated with that public address. Traffic can flow out, be associated with the dynamic port, and then traffic can flow back in upon that same public address that you assign. Okay. Ultimately, though, yes, these are the various services that can utilize these public addresses, but the main thing here is just to remember the reasoning. You could just go in and just add a public address without using a prefix, no problem. The problem always is that it's not always a problem. I should say in some companies it's a problem. The issue involves the fact that Microsoft will just generate an address for you, or give you an address that's in a pool, and you don't really know what order that's going to go in. By setting up these prefixes, you will be aware of what the addresses are going to be. Like right now, I can go right here and I can look, and I know what my 4 addresses are going to be just by looking at that right there. Okay, so if I needed to go and set any kind of rules in place or anything like that, I needed to already know what these addresses are. If I was working with a customer and I needed to go ahead and give them a heads up, hey, I'm going to be deploying this resource that's going to communicate with your on-premise network, then you can go ahead and give them the address before you've even applied the resource. Whereas, you'd have to create, and I'm only doing 4, but imagine if you had to do like 16 of these addresses, and just creating one address after the other 16 times is a lot of trouble. This way you're knocking it out in one go. All right. So that's the idea here, and those are the different uses that you can get out of setting up a public IP prefix. In this video, I want to explain the concepts of using a custom IP address prefix, also known as bring your own IP address or addresses. So what is a custom address prefix? So this is a concept in which if you own specific addresses from the internet, maybe you have worked with your ISP and you have registered specific static IP addresses that get routed to your on-premise network, you can actually associate those with Azure. But you basically have to authorize Microsoft to do that. Okay. Once you've authorized, and I'll talk a little bit more about that in a minute, how that would happen. Once you've authorized that, then Microsoft's routing tables will associate those addresses with their environment. And of course, you will be registering through the ISP or whoever you registered these addresses through. They'll update their routing tables, and traffic will begin to be able to flow into the Azure environment for those addresses. Okay. And so the idea here is I might already own a block of addresses. Take a company that maybe has owned, there are companies out there that have leased static addresses from the internet since the 1990s. Some of them have, thousands upon thousands of addresses, especially in large organizations that they have paid for decades, and if they want to utilize those in association with Azure, they can. A lot of companies are moving to the cloud, so these static addresses are now beginning to be associated with the cloud. Okay, they use them on their wide area networks, and since Azure is now providing a wide area network for companies, then they want to be able to associate those addresses with their cloud environment. Okay. So what are the benefits? Well, the main benefit here is, again, the customer, you, the company that owns these addresses, get to keep these addresses that they have already purchased or leased from their ISP. And in a lot of cases too, one of the benefits there is that, you know, if this is a company that's been around for a long time, they might have partnered up with other companies, and these addresses have already been added to white lists, allow lists, and so they don't want to lose that. Okay. Now these public addresses and you know, basically get a standard SKU, standard stock keeping unit, and you know, get associated into Azure service that way based on a standard SKU, same as you would have with the regular public address. Okay, and they operate exactly like regular public addresses do in Azure once this all happens through the routing table system. All right. So it's when you set this up, it's a three-phase process: validation, provision, and commission. All right. So the beginning of this, though, is that whoever your company has purchased the addresses through, whatever ISP, Internet Registrar Authority, whoever they've gone through, they have to fill out a form called the ROA. The ROA stands for Route Origin Authorization. Okay. So Route Origin Authorization. This is a form you fill out, and once that is completed, you get a self-signed certificate associated with that, and then you go on to Azure and you basically add a resource called custom IP prefix, and they're going to require you to specify when the expiration period of that ROA form expires, which is information you'll get once you fill this out. Okay. From there, you will, once you've filled all this information out and you registered through Azure, at that point, these addresses will begin replicating into the Azure routing tables. So again, you're going to add the resource into Azure. So you just go to all services in Azure, search for custom prefix, custom IP prefix. You fill that out after you've filled the ROA out, and then it processes through. Now, the limitations of this. Custom prefix can only be associated with a single Azure region. So you cannot, this is not a cross-region thing. For example, if I register some addresses with East US, then they're going to be registered with East US. It can't be East US and West US or Central US or, you know, any of the European regions or any of that. It's going to be associated with a single region. Okay. With IPv4, can be equal to, as far as prefixes go, the /21 or /24 prefix. IPv6s do support the /48. Okay. Another thing is, with custom IP prefixes, they don't support the ability to do routing preferences through the global tier for cross load balancing. So when you start thinking about load balancing in various regions of the world, since this doesn't support multiple regions, these addresses can't be load balanced that way. Okay, so you do have to consider that. And when you do set this up, these addresses have to be associated with a zone. Remember that in Azure, each region has, on average, 3 zones. Each zone is sort of like a data center in that zone. Okay. And the idea is if one data center goes down or one zone goes down, you have 2 other data centers or 2 other zones in that same region that are up. But you have to associate a public address with a specific zone. So it'll either be 1, 2, or 3, and that's where the initial routing table is going to be associated with in Azure for that. All right. The other thing is the advertisements of these IPs and custom prefixes over ExpressRoute are currently not supported. I'm sorry, aren't currently supported. So they are not supported in regards to advertising this over ExpressRoute. All right. Another thing is, once this address is set up, these addresses are set up, you can't move them between subscriptions. So they're going to be tied to whatever subscription that you link this to, and you can't move it after that. Okay. Another thing is you can't move these within different resource groups either. So it's a single subscription, specific resource group. All right. And lastly, when you do set this up, it can take up to 2 weeks before everything is fully activated. Okay, so IPs that are brought into Azure can have a 2-week delay before they can be used for any kind of server activation or any usage. So keep that in mind. It does take a while for the routing tables to replicate. It doesn't normally take that long. That's sort of like the maximum, though. It's kind of like how in DNS that they say, oh, in DNS it could take 48 hours for DNS to replicate, but it happens a lot quicker than that. It's that sort of thing. So just keep that in mind. All right. So hopefully that gives you a better understanding of using custom IP prefixes. I won't say this is a very commonly used thing. Not a lot of companies are using it. It is available, though, to companies that can use it and can be beneficial to those companies. I'd now like to walk through creating a public address from my custom IP prefix. So here I am on portal.azure.com. And I'm just going to click the menu button, go down here to resource groups, and we'll click on demo RG, where I have created a public IP prefix called public prefix demo. And so right here is my addresses that I've got available. I have 4, and as you can see, I've allocated 0 out of 4. I'm going to click add IP address. Okay, and perhaps this address is going to be for a VM called VM1. So I'm going to say VM1, and I am going to associate it with a DNS name. We'll say VM1 ELP for exam lab practice. Nobody is using that full DNS name, so that's fine. And we've got an idle timeout of 4 minutes, which just simply means that when a session is established with this IP address, it will keep that session alive for up to 4 minutes, even if the client side of the session has not made any contact in up to 4 minutes. After the 4 minutes, though, it'll terminate the session. Okay, so from there, we're just simply going to click add, and it is now going to generate a public address. So we'll go ahead and let that go through. As you can see, it didn't take very long for it to run through. And we have it says allocated IP addresses 1 of 4. Okay, and as you can see, if I click on public IP addresses blade here, you can see VM1, which I haven't actually created a virtual machine, but you can see the address that's associated with it. It also has a DNS name associated with it, which of course you could associate your own DNS name with this address, but I'm not going to get into that right now. Okay. But as you can see, very easy to allocate one of these addresses. So I actually have my public IP prefix that I've created, and if I go here to the menu button on portal.azure.com, click the resource groups, go to demo RG, and click on my public prefix demo, which is the public IP prefix, I have allocated 1 address of these 4. If I go to public IPs, I can see that, and I've called the public address VM1, but I haven't actually associated it with anything yet. So I'm going to just run through real quick creating a virtual machine, and we will see how we can associate it. So I'm going to click the menu button here, and I'm going to go down here to virtual machines. Remember, if you ever do this and you don't have virtual machines showing up here for some reason, you should, but if you don't, you can always go to all services and do a search for it. I'm going to go to virtual machines, and I'm going to click to create an Azure virtual machine. All right, I'm going to store this in my demo RG resource group, and I'm just going to call it VM1. It's going to be associated with EastUS, and I'm not going to really worry about redundancy. Not going to put any of that on. I'm just going to go with a Windows Server 2022 Data Center Edition. Okay, and I'm just going to go with this default size. 2 virtual CPUs, 4 gigs of RAM. And I'm going to say ELP admin will be my admin name. Keep in mind that it wouldn't surprise me if your screen looks a little different than mine. No matter how often I update my videos, Microsoft changes the screen, it seems like, week after week after week. So don't be surprised if it looks a little different. And remember, this is not a video teaching you the intricacies of creating VMs. Hopefully you already know how to create VMs. So I'm just creating a VM very quickly for demonstration purposes. I'm going to leave RDP on. I'm going to click next, and I'm just going to go with a standard hard disk drive, save on Azure credit, and then networking. So we get over here to networking. All right, I want you to notice it says public address. I can drop this down and I can select that VM1 IP address that I created earlier. So that's how I can very easily associate that address if I want. All right, so I'm going to click next. All right, from there, I'm going to turn on auto shutdown, and I'm going to set that for 7 p.m. Eastern time in my case. All right, so let's go Eastern time, and I like to do that just so that, you know, if I forget to shut this VM down, it'll shut down automatically, and it'll save on Azure credit. I'm going to click next. I'm going to turn off the boot diagnostics to save on Azure credit, and then we're going to go next, review and create. All right, and validation pass. I'm going to click create, and I'll go ahead and just pause the recording for a moment while this is getting created. All right, as you can see, this is complete, and I'm going to go right here to the resource group demo RG, and I want to show you the public prefix demo here. If I click on that, I can see allocated addresses 1 of 4, but here's where I really want to show you. If we click on public IP address VM1, you can see that it has been associated with VM18. Now, why does it say VM18 and not VM1? Because that's actually the virtual NIC name. So it's given a virtual network interface name. So that address has been associated with that VM. All right. And so if I wanted to remote into that address, I actually could. I'm not going to demonstrate that in this video, but you know, I could very easily, if I go back over to my virtual machine, I can connect to it through RDP using that public address, okay? And I could remote into it, okay? Which, again, I'm not going to do right now, but I just wanted to show you how we could now associate it. And that's what we've done. So we've actually gone through the process now of creating the public IP prefix, we've allocated address, and now we've associated it to VM1. Let's talk now about how Azure is going to deal with DNS involving VNet. So DNS is our domain name system, domain name space, domain name service, whatever you want to call it. People have various names for it. The idea of DNS, of course, is to associate names or words with IP addresses, and Azure is going to offer a couple of different possible solutions for dealing with name resolution. One would be to do what's known as public DNS, all right, name resolution. Now, with public DNS name resolution, the idea is, let me just kind of clean this up a little bit, but the idea is we have a DNS service, all right, DNS service, which provides what's called a zone, which is basically a database, okay, that gets associated inside of Azure. All right. Now this DNS service, if you're doing a public DNS service, okay, then the idea is we can have a registrar, a company that is hosting the name. For example, I host my name resolution through GoDaddy, and now some people like GoDaddy, some people don't like GoDaddy. I've just been with GoDaddy now for so long, I've just kind of stuck with them. But when I register a name, like for example, if I register examlabpractice.com, I've registered that through GoDaddy. Now what can happen is I can take a public name like examlabpractice.com, register through GoDaddy, and I can have GoDaddy out on the internet point to Azure for the DNS service. So I can actually go into GoDaddy, I can edit the name server records that are in Azure, and I can point to the DNS service here, okay? A good example too, maybe I don't want to point the whole examlabpractice.com service. For example, I'm actually hosting my web server for examlabpractice.com. I host that through through the GoDaddy web hosting service. And I could host it through Azure. It's just cheaper, honestly, at this point to go through GoDaddy because it's not like a massive site or anything. Now, if I needed more control, I would definitely want to host it through Azure because Azure is going to give me complete and utter control, and I can scale way better than I could with GoDaddy. But right now, GoDaddy's fine. But let's say that I was going to provide support for my service. Okay, I could host the public name support.examlabpractice.com. Let's say I'm going to host that. So I'm going to create a zone called support.examlabpractice.com right here in Azure. So anytime somebody goes to anything involving support.examlabpractice.com, maybe they get sent to Azure. And maybe I've got a web server that this service is going to link to. All right. So this service that's hosted in Azure is going to take that name. So anybody that goes to that name out on the internet, GoDaddy is going to refer support.examlabpractice.com to the Azure service. And then what can happen is I can have records. For example, I could have what's called an A record or a CNAME record for www, and I could point it to whatever address I want. Okay, so for example, if I was hosting the web server here in my Azure environment, I could have that web server. I could link to that web server. For example, VM1, let's say that's my web server. We'll just kind of clean this drawing up just a little bit, but let's do say that I've got a virtual machine. Let's say that virtual machine is this VM1 here. We'll say this is VM1, and so what would happen is it would link to that VM. So anytime somebody goes to www.support.examlabpractice.com, GoDaddy would refer them, because GoDaddy is the internet registrar, would refer them to Azure's DNS, and then I would have a record that would link them here. So that's the idea of public DNS name resolution. Now, there's also what is called private DNS name resolution. All right. So you can do private. Okay. And let's say for private, maybe the idea with private is I'm going to host a zone that's just private to Azure. It's not publicly accessible from the internet, and maybe I want each one of these VMs to refer to it. So I could create a DNS service, okay, that's basically private DNS service, which is going to be a zone database just like the public one, so zone DB, okay, but it's going to be a private zone, and maybe that private zone, let me just kind of move this around a little bit here. Let's do this. Let's move it over here just a little bit so I've got enough room. Okay. And that is going to be, maybe it's going to be examlabpractice.internal. Okay. And so each virtual machine can get a VM1, VM2, VM3, VM4, VM5, whatever the VMs are called, and they'll all have a private name. So, for example, you might have VM1.examlabpractice.internal. The key here, though, is to remember that this is private to Azure only. This is not publicly accessible. Now, I will say that if you have set up an on-premise environment, like over here, and you've connected your on-premise environment with, say, a VPN gateway or ExpressRoute or something like that, you will be able to communicate with that internal service, that private service. You will be able to communicate with it. You will be able to type things like vm1.examlabpractice.internal and reach these names. There's nothing special you have to do. You don't have to link to your registrar like GoDaddy or anybody like that when you're using a private name. Okay. All right. So those are the two different name resolution services that Azure provides: a public name resolution service and a private name resolution service. Let's look now at some of our DNS options available in Azure regarding our VNets. Now, the first thing I want to show you is that when you add a Azure resource, such as a virtual machine, Azure will provide a dynamic name that can be associated to that resource that's publicly accessible if you have a public address. So to see that, here we are on portal.azure.com. If I click the menu button here and I go to virtual machines, you will see I actually have a virtual machine called VM1 that I've created earlier. If I click on VM1, all right, you'll see that I have a public IP address that's been associated with that, and then there is a DNS name that has been given to that resource. So when a public address is associated with a virtual machine, a public DNS name can be associated and with that address. Okay, so that's the first thing to know involving DNS and Azure, is that Microsoft Azure will associate a DNS name, and this is a publicly accessible name. If I was to pull up like command prompt right now and I said ping this address, you can see it's not going to let me ping it because there's a firewall blocking it, but you can see the address that it gets resolved to. Okay, same thing if I was to do an NS lookup, okay, against the name VM1 ELP eastus.cloudapp.azure.com, okay, you can see the name getting resolved right there. So it is resolving the name, and so it is working. Okay. So clicking the menu button here, going to my virtual networks, let's click on VNet 1 hub. All right, I have my address space here, and my address space for this, I've got peerings set up. But if I go back over here to overview, you will see DNS services, Azure provided DNS service. Okay, so right now it says by default resources deployed to a virtual network are Azure DNS for domain name resolution. To use a different one, you can select custom. At that point, if you want to point to a DNS server of your choice, if you're hosting the DNS server somewhere else and you would like to point somewhere else for DNS, you can do that. Azure will allow you to do that. Okay, so if your company is, like for example, I use GoDaddy. If I'm using GoDaddy and I wanted to point to GoDaddy's DNS for name resolution, then I could put in the GoDaddy addressing system address for name resolution on that VNet. So what would happen is anytime a server, like a virtual machine, boots up and it gets an address from the DHCP service that Azure has, it's going to point to this DNS server for name resolution, unless you statically tell the server to use something else. Okay, but I'm not going to do that because, of course, the point in this whole lesson here is to allow Azure to handle everything. So, but I did want to point out that you could do that. All right. So those are some of the considerations, and in this lesson I'm not going to get into the fact that you can create public DNS zones and all that, but you do have the ability to, if you do a search for DNS, you can add DNS public zones and private zones, but I'm not getting into that in this lesson. But those are the things to consider when you first start working with virtual networks in Azure. Those are the things to consider as far as the basics of DNS is concerned. I'd now like to get more into how we can host a DNS name in Azure to be used by any of the virtual networks in Azure, as well as even if you had linked your on-premise network to Azure, this DNS can be hosted in Azure. Now, I own the name examlabpractice.com. I purchased that name through GoDaddy. Okay, been with GoDaddy for years. I've just kind of stuck with them. But let's say I wanted to no longer be hosting DNS in GoDaddy, I want to host it in Azure. Now, GoDaddy is not only a DNS hosting company, but they are also a registrar, an official authority when it comes to hosting a name. So if I'll jump into my GoDaddy account right now and I'll show you. As you can see, examlabpractice.com is right here, hosted in GoDaddy. And if I scroll down, I have an option right here to change DNS name servers. You can see right now it's being hosted by GoDaddy. These are their servers. So what I can do, jumping back over to portal.azure.com, I can click the menu button, go to all services, and just do a search for the word DNS. Click on DNS zones. okay, because DNS zones is a public zone. I'm going to click Create DNS Zone. And then I'm just going to choose the demo RG as my resource group, and then I would put in the name I want to host, examlabpractice.com. All right. Says, is this a child domain, child of an existing zone? No. So I'm not going to check that box. Then I'm going to click Review and Create, and then we will click Create. Now what's going to happen is Azure is going to create this DNS zone, and then what I can do is I can go to Resource. You see these name records right here? I can go right in here and I could change to those name records. I could add the 4 name records that you see right here. And at that point, it'll take a little time for it to replicate and everything, but at that point, Azure will now be hosting that public DNS namespace. Okay? And so that is how you could move your DNS hosting into Azure. Now, I'm not going to do that. The reason I'm not going to do that is because I'm hosting a website and all that in GoDaddy, and I don't want to disrupt any of that right now. But that is the process for moving this public DNS namespace into the Azure namespace, or into the Azure service. Now I want to look at creating a private DNS zone. So here we are on portal.azure.com. Click the menu button, go to All Services, and just do a search for DNS here. You'll see I have private DNS zone. So I'm going to go ahead and click that, and we're going to click to create a private DNS zone. I'm going to store this in demo RG, and let's just call this examlabpractice.internal. Okay, again, this is going to be a DNS name that is linked to our internal VNets, and it's only going to be accessible to our internal VNets. And of course, it is possible to link on-premise devices or on-premise networks using a VPN gateway or ExpressRoute. We could link all that into Azure, and they could communicate with these services as well if they can communicate with the VNets. But ultimately, this is just for internal purposes. This is not going to be accessible from the internet. So we're just going to go ahead and click Review and Create, and we'll click to create. All right, so this will take just a few seconds to create. All right, and while this is getting created, I want to jump over. I'll just open up another tab. We'll go over here to Virtual Networks, jump over here real fast. And if we click on our VNets like VNet 1, the hub, we're just going to check. So you'll notice it says DNS servers, Azure provided DNS server. So that's automatically set there. Unless I change this to custom and point it to some other DNS server that I want to manage, that's what it's going to be using. It's going to be using Azure DNS provided service. So I'm going to jump back over here, and you can see that it has been completed. I'm going to click Go to Resource, okay, and I don't have any records. So if I wanted to create a record, for example, maybe if VM1 was going to be my, maybe VM1 is going to be my web server for this internal service, and I want to create a www record, I could look at VM1, and if I go here to VM1, go to the menu, go to Virtual Machine, click VM1, click Networking, you can see my address is 10.1.1.4. So I could go here and create a record. Just put www, for example, we'll say 10.1.1.4. But there's still something else we have to do. When you consider this, I'm not going to get deep into it in this one, but we do need to be able to utilize virtual network links, which is where we're going to link to our VNet. I'm not going to get into that in this video, but I did want to point that out. Now, I could create other records if I wanted, CNAME records and all that if I wanted to have another name. I could have I could even say VM1, and we could link that to www.examlabpractice.internal. And so now we've got 2 records that kind of link to the same thing. So if you go to VM1, it's going to link to whatever this address says, and that's the kind of the idea of a CNAME record is it's an alias. So you have www. Granted, I could have done it the other way around. I could have created an A record called VM1 and had a www CNAME record that linked. It doesn't really matter. You could do it either way. All right, but that is how we can create our private DNS zone, and that's how we can create a couple of records in that zone. I now want to look at the configuration of public and private DNS zones. So we'll start with public DNS. So here we are on portal.azure.com, clicking the menu button, going to all services, and I'm just going to type DNS and go to DNS zones. That's going to bring me into the public DNS zone. So we'll go there. We'll click on our exam lab practice name. And as you can see, we just have a couple of records, NS record and a start of authority record. The NS record is pointing to the Azure DNS services, and the SOA record is a configuration record that has different intervals in it that DNS uses. So I'm going to click on to create a record set here. And so if I wanted, let's say I could say www, and we could point an A record here. There's various records I could choose, and then I could point to an address. So let's say, for example, that VM1 was actually my web server, okay? If VM1 was my web server, we could figure out what the VM1's public address is, all right? Let me jump over to another tab. We'll click the menu button here and go to virtual machines. Click on VM1, all right? And we can see what VM1's public address is. So I'm just going to copy that, and then we can paste it right there and click OK. At that point, this record is created, and if I really did, now I didn't point my GoDaddy here, my GoDaddy exam lab practice name, but if I did do that, then you would be able to type www.examlabpractice.com and it would refer to this address. Now granted, I would need to set up a web server and all that on that VM, which I'm not doing in this video, but at that point, that address would be accessible from the internet. Now what about our private DNS zone? Let's go to the menu button here, go back over to all services, and I'll just search DNS again, and we'll go to our private DNS zones, and there is examlabpractice.internal. We'll click on that, and so if I want, I could create a record to www. This time though, we'd put the private address, because this is internal to Azure. So if we go over to VM1 and we go to networking, okay, you can see what the private address is of our NIC on this VM. So if I copy that, I can go back over here, I can paste that in, and I can click OK. And so now, if you were to go to www.examlabpractice.internal and you were doing this from within the Azure network, like maybe one VM talking to another VM, we could do that. Okay. Or if you just wanted to create a record called VM1, you could do that as well. VM1 and point to the same thing, right? 10.1.1.4. Click OK, and so you've got a record for that now. And so this is a way for your VMs to identify each other using this DNS name. Okay. All right, so that is how you can configure records for the public and private zone databases inside of Azure. Let's now see how we can link a private DNS zone to a VNet. This is actually very, very easy. So here we are on portal.azure.com. Click the menu, go to all services. I'm just going to do a search for DNS. Click on my DNS zone. Oops, actually I need to click on my private zone. So we'll go here to private DNS zone. So examlabpractice.internal is my zone I've already created. If I click that and I go right here to virtual network links, currently this DNS zone is not connected to any of my VNets. So if you have a VM like VM1 that's sitting on those VNets and you want that virtual machine to be able to utilize this name resolution, you're going to need to add it. So we'll click add, okay, and I'll say hub link. And we'll just select the hub. All right, at that point you have auto registration. They tell you that the setting's going to enable the automatic creation of DNS records in the private zone. So if you want to just automatically create the records, you can. I've actually already created a record for number 1 there for VM1, but you can have that automatically happen. So we just click add, and then I could add another link. I could say, VNet 2, which is a spoke. Give it specify it, auto registration. We'll click add. We'll go ahead and add another VNet 3 spoke. We'll select number 3, auto registration, and then we'll do VNet 4 spoke, and we'll select number 4. All right. And as you can see, that's it. That is how easy it is to link your private DNS service to those VNets. Okay. It does take it will take a minute or so for all these to show. Actually, it's happening pretty quickly this time, but just be aware that it does take a little bit of time. You can see it's still actually in progress on these. But that's it. That is how you can link your DNS service to a VNet. Let's talk about the concepts now of what's called a Azure DNS resolver. So an Azure DNS resolver is how you can connect a private or internal DNS zone like this private DNS service, such as examlabpractice.internal. That's how you can connect that with an on-premise network. So if you have clients that are on-premise and you're connected to Azure using a VPN gateway or ExpressRoute or something like that, these clients can communicate with this service and utilize this internal service. But there's a couple things you have to understand. All right. So you can add this resource, and when you add this resource, you have to have at least 2 subnets, what's called the outbound rule subnet and the inbound rule subnet. And these actually act as what are called endpoints as well. So these outbound subnet is an endpoint, and the inbound is a endpoint. And so what happens is, like, I could have subnet A could be my outbound, subnet 1A, subnet B could be my inbound. Granted, I would warn you, you wouldn't be able to have an Azure firewall on there. That would have to be a different subnet, okay, for that. So we'll just take that, out of the picture. It's going to look a little bit ugly for a bit here, but just kind of fix that. But anyway, you would have to have an outbound and inbound endpoint. And what happens is you would be pointing your endpoints to a DNS server that would be on premise. So you would need a DNS server that is on premise in your on-premise network that your clients are communicating with. So any client computers that you have in this on-premise network, they're going to query their own DNS, and that DNS service is going to forward this to Azure. So you just enable what's called a forwarder on your internal DNS server. It's going to forward it to Azure, and then what will happen is Azure can reply back. So you'll have an inbound accepting the inbound, this inbound endpoint subnet, and then when these machines want to, if these machines want to communicate and reply, if anything's replying back, then you've got the outbound. So you have an inbound and an outbound endpoint that's handling that. Okay. Now, obviously, this is hard to see unless you've got an actual DNS server on-premise you can try this out with. But let me jump into Azure now, and I'll show you how we would create this. So here I am on portal.azure.com. If I click the menu button, go to All Services, and just do a search for DNS Resolve. If I put those keywords in, I can find DNS Private Resolver. So if I click that, I can click to create. All right, and specify my resource group, DMRG. I'll just call this DNS Resolver ELP for Exam Lab Practice. And then we'll select the hub VNet. All right, then we'll click next. This would be where you'd set your inbound endpoint. All right, so I have an inbound and an outbound. Right, I would select the subnet I want to use. Subnet 1A will say this will be inbound. And then I'll click save, and then I'll click next, and then you have an endpoint for your outbound. All right, we'll just call this outbound. Select the other subnet. So again, if you look here, the outbound endpoint can forward the domain name resolution request to the DNS server specified in the rule set, which I'm about to show you. To complete your configuration, create the rule set. If I go previous and I look at the inbound endpoints can receive domain name resolution request. So that's what we're doing. Then you got your rule set. Rule sets define conditional forwarding rules for DNS traffic using outbound endpoints. Tells you can create these now or you can do it later. Okay, so at that point, if I say now, rule set for resolver, if I give that a name, specify the outbound endpoint there, the virtual network, and then I would add my rule. And this is about as far as I can go with this, because I don't actually have a DNS server set up on premise. But if you did have a DNS server set up, you'd have to have connectivity with that DNS server, either using a VPN gateway or a express route. So I could say on-prem DNS is what I'll call it, and the DNS name we'll say is DNS1 dot examlabpractice.com. All right, and they do require you to put a dot at the end of it. And the rule set would be enabled. You would add your destination. This would be whatever the address is of the server that's on premise. Okay, so I'll pretend like it's that one, and then I would click review and create, and then you would click create, and at that point you will have done this. All right, I'm not actually going to create it just because it's a waste of Azure credit, just because I'm not actually using it, because I don't actually have an on-premise DNS server. But if you did set up an on-premise DNS server and you had linked with VPN gateway or express route, this is how you can set your forwarding service up, so that the traffic would be able to communicate with that DNS server. All right, so that is how a DNS private resolver works in regards to Azure. Hey, this is John Christopher. I hope you enjoyed getting to experience a little bit of this course, and I hope you'll join me on the full adventure. If you'll check the description of this video, you'll see a link that'll show you how you can get access to the full course. Now, in the full course, you're going to learn how to set up a practice environment where you can practice hands-on, and I'm going to provide you with lots of virtual simulations that you can do 24/7. All you need is a web browser. So I hope you'll join me, and I hope you'll also give me a like and subscribe. I'm trying very, very hard to get this channel to build and grow, and so I hope you'll take the time to do that.